Hey kids, Creepy Baby here with another episode of the Physics Podcast. We're standing here in an elevator to look at some of the unique situations that show up when you're riding in an elevator. Now, the forces themselves are simple. There's only two forces, weight and normal force. Normal force pointing upwards from the floor, weight pointing downwards. Now, in situations like this, there's a term called apparent weight. Your actual weight is mass times the acceleration due to gravity. That never changes. But as we'll see throughout this video, the measured weight changes due to the motion of the elevator. That's actually, if you're staying on a scale, the normal force, or in this case, we could call it the tension of the spring scale. But the apparent weight would be the measured weight that changes. And in any type of problem, when they say apparent weight, that would mean the normal force. But when we set the elevator in motion, some interesting things start to happen. We're on the first floor now, moving up to the third floor. Going up puts us in a upward being positive frame of reference. Now if we're on the first floor going towards the third floor, when we first begin to move up, that makes us have a positive acceleration. When we solve our equation for the normal force, that gives us normal force equals positive ma plus w, so the normal force is greater than the weight. But when we slow to a stop as we approach the third floor, that gives us a negative acceleration. So when we solve our equation for normal force, it says normal force equals negative ma plus the weight, which actually gives you a normal force less than the weight. Now, if we go back down to the first floor, when we first start moving, that puts us in a downward being positive frame of reference. So our equation becomes weight minus normal force equals ma. When we first begin, it gives us a positive acceleration. So weight minus ma equals n when we solve for normal force. When we slow to a stop, that requires an upward acceleration. In this frame of reference, though, that's a negative acceleration. So when we solve for normal force one more time, we get weight minus normal force equals negative ma, or w plus ma equals n, giving you a normal force greater than the weight. So there's a lot of positives and negatives to keep track of when you're in an elevator. And the trick is to just let the direction of the velocity be positive and let all other upward and downward numbers follow that convention. You'll get the problem right.